Good evening, everyone. Welcome to the third in the series of our Cornwall Archaeological Society Winter Lectures. It's lovely to see so many people. I can see on the screen how many people have logged in. This is our best audience so far, I think. We're welcoming this evening Dr. Soetkin Vervust and Pete Herring, who are going to talk to us about the early origins of Bosigran's famous fields on the cliffs above Zennor. Let me tell you a little bit about them. Dr. Vervust is a research fellow at the McCord Centre for Landscape at Newcastle University and the Archaeology Department of the Vrije Universiteit, Brussels, Belgium. She's a landscape archaeologist with a background in physical geography, geoinformatics and historical cartography, and studies the historic character of landscapes through GIS analysis and scientific dating of earthworks through optically stimulated luminescence. And Pete Herring, of course, will be known to a lot of you. He's a landscape archaeologist with over 40 years experience working for the Cornwall Archaeological Unit and Historic England. He ended up leading the Strategic Historic Environment team at Cornwall Council, and he surveyed, interpreted and characterised historic landscapes throughout Cornwall, including Bodmin Moor, the China Clay Country, Kit Hill, Godolphin and Launceston. Among the surveys he enjoyed most were those unpicking the ancient field patterns of Zennor. So we welcome them very warmly and look forward very much to their lecture.
Thank you, Caroline. I'll proceed, I think.
Yes, you're there, Peter.
Yes. Thank you, Caroline, and thank you, Millie, for setting this up so efficiently. So we're going to be talking in turn, so I'll go first and introduce the landscape. Soetkin will then discuss the recent work done using OSL dating, and then I'll sum up at the end. So this is where we're working at Bosigran in Zennor, beautiful photograph by Steve Hartgroves. You can see cliffs, a coastal plateau, downs and tors. And from the 19th century, antiquarians and then archaeologists have regarded this as an ancient landscape. Hingston Randolph in 1889 saw, as he looked across the coastal plateau, some fertile garden extending as far as the eye can see, oasis-like, betwixt the desert and the sea. It had been the scene of the rude husbandry of an uncivilized but industrious race. And that is how many people saw these small irregular fields of Zennor and West Penwith. O.G.S. Crawford, the great landscape archaeologist, one of our inspirations, in his article, The Work of Giants, suggested that they might be prehistoric by using landscape archaeology techniques. Landscape historians like W.G.V. Bulchin and W.G. Hoskins asserted that they were prehistoric, but didn't really provide evidence for it. When it came to our time in the 1970s and 80s, we needed to establish the field's significance, including their age. We needed this to inform decisions and to prioritize use of resources for planning, protection, and management. Right. So were the ancient fields really ancient, and was the apparently traditional land use also ancient in Zennor? Was the mixed farming on those plateaus, fields, and in the valleys between the blocks of fields on the plateau all ancient? Was the summer grazing on the downs and on the cliffs? Was the cutting of fuel, the furze and the turf, and the ferns for bedding also ancient, as it had been suggested by looking at the diaries of James Stephens, for example, and the tithe maps, the information on those? Were they medieval or prehistoric as well as modern? Well, in the 1980s, The National Trust, who were acquiring much of the land in Zennor, or were acquiring covenants over the use of that land, and the Cornwall Committee for Rescue Archaeology, what later became CAU, Cornwall Archaeological Unit, devised a programme of surveys, the West Penwith Survey, mainly under the direction of two people in that photograph at the top left, Nick Johnson and David Thackeray. Nick Johnson of CCRA, David Thackeray of the National Trust. And they organised surveys, of which I was lucky enough to be part, which worked their way across Zennor, surveying by hand with plane tables and alidades and tapes, doing offsets from straight lines, as you can see in that photograph, drawing the field system in the field so that you could see the plan developing under your eyes, recording the lines and the shapes of things, but also recording the relationships between things, between the features, between boundaries and other boundaries, and between boundaries and dwellings like these courtyard houses here. And we use those records to work out relative chronologies, that is, sequences within patterns, working out which bits were earlier and which bits were later. And we use things like physical relationships, the way that some features abut others, run up to and join on to others, the way they cut others or ride over them, so you can see direct physical relationships. We also looked at functional relationships. We could see things apparently being laid out with respect to earlier ones. And we could see that some features were robbed to create later ones. And through all those devices, we can work out a sequence. And as we developed our understanding of the place, we recognized that certain types of boundaries, like this dry stone wall here, would be typically, because of that relative chronology that we were developing, late. So they could be 18th or 19th or 20th century. Whereas the Cornish hedges, rather like these in the distance here at Rosemergy, the stone-faced earth walls could be recent, but they could also, through this relative chronology, be seen to be very early. By doing all of this relative chronology, we were able to develop histories and prehistories, or a story, a narrative of Zennor. So what we'll be doing now is diving in a bit more deeply into Bosigran. So Bosigran is at the western end of Zennor. It's got a very rich field archaeology. It's got examples of most of the kinds of assets or monuments and buildings that we find throughout Zennor and throughout West Penwith. If we could understand Bosigran, you might think you can understand West Penwith. So when we produced the recent report on the West Penwith surveys in 2016, cover of it in the bottom right, we have a chapter taking Bosigran as a case study. And we have a series of maps of Bosigran working through the relative chronology. And this is the first one. And you can see the very earliest features. So here we have on the summit of Carngalva a tor enclosure, a more detailed plan of it here. That could well be early Neolithic if it really is like Carnbray or Helman Tor that have been excavated. There are prop stones on the tor along the back here, which Tony Blackman and Dot Blackman discovered. There are later features. There are Bronze Age cairns, a little line of them here and a couple more here. Some curvilinear fields, which might be earlier Bronze Age. But what we're interested in tonight are these fields here on the plateau itself, coaxial fields. And here we go into those in more detail. So they're called coaxial because they have long boundaries which share the same axis, well, roughly share it in this case, two main long boundaries which have then been subdivided with cross banks. You can see that they're in an area with little green dots. Those little green dots are clearance heaps, so the land seems to have been cultivated. And when Soetkin shows this boundary in more detail later, you can see that some lyncheting has occurred here as well. And there are four structures here which might be roundhouses, which might relate to it and be the homes of these people. They would make a small hamlet, and a coaxial field system like this ought to be worked communally. Otherwise, you wouldn't need the order that we have here, the organization of the land, so regularly. When we surveyed this and when we analyzed the surveys, we saw that this was early. It's earlier than these fields to the north here, which cut across them. So those are later fields than the coaxial fields, and they're also earlier than these fields down here, which are abutting the earlier fields, the coaxial fields. So in a very simple way, we could see that these were amongst the earliest features on the plateau. They're very similar in some ways to the Dartmoor Reeves, and they were being investigated at roughly the same time by Andrew Fleming, and a Middle Bronze Age date of roughly 1500 BC was suggested as a result of that. And there are other coaxial fields in Zennor. There are some more on Zennor Head itself and in Travail, on the cliffs at Travail, and also on the hills at Tregerthen and Tremedda. We'll look at those fields again later with Soetkin, and we'll also look at these fields, which are the principal fields at Zennor. Those coaxial fields that I've just mentioned are here in this bit of rough ground called Haldrine Croft. But we'll now look at the field system here, which makes up the bulk of the fields that are still farmed by the scamblers of Bosigran. Well, these fields are not as irregular as they might appear now in the aerial photograph or on the map, because many of the boundaries have been removed and these were smaller than they are now. Reinsert those lost boundaries and we have a fairly regular field system, as we'll see on the next slide. But even from this aerial photograph, you can see that there are strong curving boundaries like those, and then subdivisions of ribbon-shaped pieces of land between those boundaries. And then there are also, as you can see labeled here, irregular fields on the cliff tops and cascading down the cliffs here outside of the regular fields. And over here in the east of Bosigran, you have a field system which is almost entirely irregular, compared at least with these. So this is the plan of those fields. And in this plan, we've inserted those boundaries that have been removed from today's farm, but which are still visible as lynchets within the fields. And we've divided them by colour into the regular fields here, which have got dark blue lines, and the irregular fields here in the east and here on the cliffs. The regular fields here appear to be associated with a hamlet. So these red blobs are courtyard houses, Romano-British houses, probably of the 2nd, 3rd, 4th centuries AD. But when we look at those courtyard houses themselves down here, there's a detailed survey of a couple of them, those two. We can use relative chronology on those as well and unpick them and see that the courtyard house here on the right derived from a simpler courtyard house with these two things added onto it, and the courtyard house itself developed from these two freestanding roundhouses by the addition of these walls to create the courtyard house. I should say that recent work by Historic England for English Heritage at Chisorster, the guardianship site, work by Olaf Beyer of the formerly the assessment team at Historic England, has demonstrated too that the courtyard houses there are later than the regular fields that we have at Chisorster, and we can say here that the courtyard houses are later than the round houses because of that chronology, and therefore this field system is most likely to relate to the period when people lived in round houses, not courtyard houses. And therefore, we suggest in our report that those blue fields are likely to be Iron Age in origin, not Romano-British. And similarly with the irregular fields here at the eastern side of Bosigran. Just on those, we won't be looking at these again, these irregular fields, but they may be irregular because there was just one courtyard house and maybe just one Iron Age dwelling here, and therefore there was no need to have subdivision and regular arrangement of the land like there seems to have been over here with the hamlet, where the 4 households, if you can see them as that, shared the land. Well, many of the prehistoric boundaries that we've been looking at are still in use, and it's these that Soetkin will be examining in a moment. I need to speed up. So there are lynchets behind some of these boundaries, as you can see. I'll just talk about lynchets for a moment. They have been examined very infrequently in West Penwith until now. There was a bit of work done here at Foge, where we can see that in the heart of a stony lynchet, there is a stone-faced wall or a stone hedge or a Cornish hedge, which we assume to be prehistoric because it's attached to a courtyard house. Roman or British maybe, but prehistoric. And its lynchet probably came to the top of the wall because in the 19th century, we know from a record of James Stevens's diary that he removed the lynchet to spread on the land as good soil in the sort of way that Graham Kirkham has recently shown barrows and other earthworks were scattered abroad and spread on the ground as manure. It's an important section really to show that every lynchet has its own particular story. I don't think I've got time to explain why I've shown this slide, other than to say that the early medieval arrangements in West Penwith show that it was no longer what we used to call the Dark Ages. It was an age or a period, the first millennium AD, of extensive settlement and careful organization of access to resources. We can see 6 levels of society, and I'll have to race through these. Those are the individual person, the basic social unit, the household, the basic economic unit, the hamlet, or the trull lands as I call them, with their land, and I've shown them here in Zennor, those places with Tre or Bos or Kerr names. Communities, which I'm showing here as the parishes, the number 3s on the map. Territories, which could be quite early. They could go back to the Iron Age if we see the hill forts as a guide to their arrangement. So Luscudgec looking after the land inside that red line, Castle and Dinas out towards St Ives, Chun up towards Zennor and St Just, and Caerbrand down towards St Berrien and Land's End. And overseeing these and organising law and order, security, and most importantly, probably a secure access for every individual household and hamlet to the commons was a king or a kingdom or a king equivalent, we can say. Going back down to Zennor, these trull lands or tenements or hamlets subdivided the land very carefully so that each one has a kind of a ribbon shape so that they can have a share of the sea, the cliffs, the plateau, the downs. The organisation of it wouldn't have been done from the bottom up. There would have been an agreement made with the community, the parish level, and the community itself would have made an agreement with their neighbouring parishes to create good strong lines like this, which they all hang off. There'll be other lines hanging off in the other direction into parishes like Gulville and Tywednac. At Bosigran itself, we can see both change and continuity in the medieval period. See change in the way that the 2 courtyard house settlements were abandoned and a new hamlet was created here at the spring head between them. The old hamlets were here and here. And we can also see change in the creation of new fields, very distinctively medieval ones, the strip fields. And we now know that strips can go back into the early medieval period in Cornwall, maybe as back at least as far as the 8th century. Those strips are attached, it's a bit faint, I know, but you can, I hope, understand that those strips are attached to the prehistoric fields which are here. So the prehistoric fields were clearly therefore still being used in their original forms. So we can see continuity as well as change. Those prehistoric fields continuing into the medieval period, and as you can see from the photographs, continuing to today. So in brief, we have recorded, we have analysed, and we've compared patterns. We've got a pretty good idea how land was used and organised, but we have only the very broadest of chronologies. We can say roughly the second millennium for the coaxial fields, roughly the Iron Age, the first millennium for the brick-shaped fields, the more regular fields. We've long needed a method of establishing dates that is independent of our archaeological presumptions, something that's scientific, that can bring greater certainty to the chronological framework over which we have draped our prehistories and our histories of West Penwith. And so I need to turn now to Soetkin, who will introduce an exciting new method of providing us with those dates.
Excellent. Thank you, Pete. I hope you can all hear me. There we go. So good evening, everyone. I'm Soetkin. I'm a postdoctoral researcher from Belgium. And back in 2018 and 2019, I was very happy to be doing research in beautiful Cornwall and was very much looking forward to coming back there tonight to deliver this talk, which unfortunately didn't happen. So I'm joining you digitally from Ghent in Belgium. So as I was saying, I'm a postdoctoral researcher affiliated to both Brussels Free University and the McCourt Centre for Landscape at Newcastle University, where I'm conducting a 3-year postdoc project. I'm studying long-term development of rural landscapes by trying to trace the origins of certain elements like field boundaries that are still present today. And for that, I use a combination of historical and archaeological data sources. I perform spatial analyses using GIS, and then I use this particular method, optically simulated luminescence profiling and dating, to add a robust chronological framework to it all. The 2 pictures you see on these slides relate to my current research, which is back here in Belgium, having a look at the coastal area, which was transformed during the Middle Ages from this natural tidal marshland to completely man-made embanked polder landscape. And so right now I'm focusing on trying to give absolute dates to these remnants of these old embankments. Next slide, Pete. But so what I was doing in previous years was work in 2 case studies in the UK, one being Bosigran and the other one being Wallington, the Wallington estate up in Northumberland. And in both, a key thing that we needed to do was try and date these field boundaries. So I'll tell you a bit more about how we went about doing that. Next slide, yes. So how do you accurately date the creation and development of an earthwork? Well, there are several options, but most of the techniques that are commonly used have particular drawbacks that make them a bit less suitable. You can try and find artifacts within these features, but then you don't always do. And if you find them, they can be fragmentary, so hard to identify and or date. And again, if you do find them, it can also be hard to relate them to either the original creation or the further development of a feature. So artifact dating is not ideal. You can turn to more scientific, more absolute dating methods in the form of radiocarbon dating. But then again, if you find carbon fragments, you're never quite sure how to relate them to your feature, or at least that's the case most of the time. They can have been subject to post-depositional processes. And if you need to take numerous samples, it can cost quite a lot of money. So ideally, when you're looking at earthwork features, you'll try and date the earth, the sediment that they're made up of itself. And for that, you can use optically simulated luminescence or OSL dating. But if you use the normal optically simulated luminescence, traditionally, you encounter the same problems as with radiocarbon dating, mainly that if you put in a dating sample, it's hard to determine where exactly in your feature to put it to get optimal results that will really inform you about when this feature was created and how it developed over time. So what we did instead for this research is combine that conventional OSL dating in the lab with a novel field profiling method. So basically we use a portable OSL reader to already determine the luminescence signal of your soil samples that you take from your feature during field work in the field. And that way you can already get an idea of the relative chronology while you're working, and then pick the most promising positions in your profile to put your larger dating samples. And if you then afterwards take all those samples back to the lab for further screening and for the actual dating, it becomes possible to not just assess the dates of where you put the dating samples, but to really assess the relative chronology of your entire profile, which is wonderful for these kinds of features. So next slide, Pete. I want to just quickly explain how OSL dating works. So what it does is it provides you with a direct age estimate of the last time that either quartz or feldspar minerals in your sediment were exposed to enough light or enough heat to reduce the previous luminescence signal to 0. And what that does is it resets your OSL dating clock. So once your sediment is then buried again and shielded from light, that luminescence signal will start to build up very slowly again over time in response to naturally occurring ionizing radiation. So an analogy that's often drawn is to compare it to a rechargeable battery, but only the charging happens very slowly over the course of years and years, while charge removal only takes a few seconds when your sediment is exposed to light. So it's very important that when we're sampling in the field that we do this in the dark. Next slide, Pete. And then only expose your samples to light when you put them in an OSL reader that then measures the luminescence signal that results from this exposure to light. So on the top left, you can see an OSL reader in the lab, and it can work with up to 40 small sediment samples, or so-called aliquots, that you put on there. And a machine like that will then not only measure the resultant luminescence signal that those little quartz samples give off, but what it also does is it administers radiation doses, known doses of radiation to your samples. And if you then every time measure the resultant luminescence signal and you put that on a graph, you can determine the radiation dose that your sample must have received while it was buried. And that's what's called the equivalent dose. So once you've determined that statistically, you can then divide that equivalent dose that corresponds with that natural luminescence signal that you've already measured in the field by the annual dose rate, so the annual amount of radiation that your sediments received. And the result of that is you get an OSL age in years that will tell you when a ground surface was buried or when an earthwork was constructed and its sediment was shielded from light. Next slide. So that was OSL dating in the lab. Now for the OSL profiling in the field, as I've said, what you do is you use a portable reader to already measure that natural luminescence signal while you're working on site. And for that OSL work, I collaborated with Dr. Tim Kinnaird, who you can see hard at work there on the second picture. He leads the luminescence labs at the School of Earth and Environmental Sciences at the University of St. Andrews. And so he came out in the field to help us with the sample. Next slide, Pete. And at Bosigran, I was also joined by some other colleagues from Newcastle University. My husband's there as well. He also works at Newcastle. So it's on the right in that middle picture, you can see Professor Sam Turner, who leads the McCourt Centre. And then you've got my colleague Maria in the back. And we were also very fortunate that we had some wonderful people from the National Trust join us. And you can see Sean Boynes there, admiring our work, taking pictures. And my thanks must also go to local farmers, Bosigran farmers, Bob and Liz Gambler, who very graciously allowed us access to their land and were very interested in the research that we were doing. So what you see on those pictures is that we've made our trenches, and now we're covering them, we're protecting them from light. And then someone needs to get underneath that dark cover to then collect these small soil samples. It's about 5 to 10 grams of soil that we collect at regular intervals down the profile. Next slide. And then we place those small soil samples in that portable reader that you can see there, and that will record their luminescence signal. What you can then do is plot those measurements on a graph that show you their position in the profile. And based on that information, you choose your most interesting horizons. And that's usually where you see a spike or an inversion in that graph, because that will tell you something about the construction history of the earthwork. And so that's where you need to place your dating samples. And on the right, you can see, for example, some terraces, and based on their luminescence profile, you can tell whether they were created by cutting down into older soil, is what you see on the top right there. So then only the exposed surface will give you that lower OSL signal. Whereas for the middle and the bottom example, some form of infilling has occurred with material that saw light more recently than your paleo surface. And that could have happened, as in the middle example, either in one go, so you get a similar OSL signal for that entire fill, or that can happen gradually. As you can see in the bottom example, if you get a gradual increase in your OSL signal throughout the fill. Next slide, please. And then finally, once you've seen that graph and you've determined your optimal spots to put your larger dating samples, you hammer in those stainless steel tubes into your exposed section to collect them. And then you take all your samples back to the lab for further analyses. And of course, you also record your stratigraphy afterwards. We made section drawings, we filled in single context sheets, we took photographs, etc. So next slide. So there were 5 sites that we investigated, and 2 of them in great detail. So number 1, I'll talk about a bit later, but I'll start with number 3, that belongs to that regular, presumably late prehistoric field system. So next slide. So this was a lynchet, quite a substantial feature. It was just under 2 meters high, and it was assumed that it was so big because it had always been in use as a field boundary since its construction, presumably in the Iron Age, and so had been collecting soil that eroded from further uphill for thousands of years. And while we were excavating this feature, we uncovered these large granite boulders, which is context number 24, right at the center of the lynchet. So we interpreted that context as the remains of the original Iron Age stony bank, and then presumed that all the material surrounding it, except for context number 4, which is your substrate, your granite substrate. So we presumed that all the rest surrounding it had been added on at a later date. So to test that hypothesis, we then collected 40 profiling samples and 6 dating samples across this entire earthwork to really get a detailed insight into its development. Next slide. And then these are the color-coded OSL signal intensities that we measured in the field with the portable reader. So you can see that they range from blue to red, so from lower to higher signal intensities. And normally your older soils in the profile that will have been shielded from light the longest should have the highest signal intensities. And indeed, here you can see that at the bottom of your profile, you get this red and this orange dots. So these are really very old soils. But then what was remarkable is that in context 27, we saw these blue dots, blue and samples, so with a very low OSL signal, which seem to be younger soils than the green ones that you get on top in context 23 and context 19. So what we assumed while we were doing this fieldwork is that when this bank was constructed, there had been an inversion of the soil and all the sediments were deposited on top of younger ones. But then when we went back to the lab, and this is the next slide, we were proven wrong, because your OSL signal intensity is also influenced by your sensitivity of the quartz. So that's how easy it is for the soil to build up this OSL signal over time. And then what we saw there was that the low OSL signal intensity in that context number 27 was not because it was exposed to light fairly recently, but because the sediment is in fact very old and therefore has very low sensitivity, hence the blue color of the dots in that context. So in fact, what you actually get in this linchet is a very normal age progression with depth down the profile. So the lower you go down the profile, the older the soils become. So next slide. And that's what you also see when you look at the equivalent doses, so how much radiation each sample had been exposed to since being buried. So those numbers also go up as you move down profile. And on this slide, you also get the larger dating samples that we took, and they show that the soils in context 27 are very old. And then context 23 and context 19, the soils there were last exposed to sunlight in the Bronze Age. Whereas on the northern side of the linchet, which is on the right, you get a dating samples that all point to the early medieval period. So it becomes a bit easier to interpret that entire construction sequence and to see the larger patterns emerging if you interpolate those equivalent doses across your entire section. And then maybe next slide. What you can also do is then calculate age ranges for your profiling samples from those equivalent doses. So it can be quite tricky to see maybe here, but bear in mind that these are not actual OSL ages that we've determined and that are on the slide in the squares. These are more age ranges, because when I showed you the OSL reader that we use in the lab, it had this wheel and it shows that you could put 40 subsamples on there to analyze, and that's what we do for the larger dating samples. Whereas for those profiling samples, we only take 2 subsamples to further analyze. So that's why you can't be as confident about the age you determine for these profiling samples. It's more of giving you a range rather than an actual date. But what's important to note here is that that soil in between those large boulders of context 24 does seem to date, based on those smaller profiling samples, to the 3rd or 4th century BC, so to the Middle Iron Age, which was quite exciting to see. Next slide, please. And then this is a bit of a summary of the sequence of construction and modification of this linchet and how to read it. So number 1 is your RAB, or your granite substrate. And then number 2 is the soil that was formed from it during the Bronze Age. And then what happened is that in the Middle Iron Age, the stony bank of number 3 was constructed by cutting down into that granite bedrock and into that Bronze Age soil, which is something that we weren't expecting originally. Then the boundary bank seems to have remained fairly low until early medieval times, which is number 4, when its top and its downhill side were further enlarged. So again, this is quite important because we'd always believed that these linchets were already quite substantial by, let's say, 500 AD, because it had been assumed that they had been collecting eroded soil on their uphill sides for almost 1500 years by that time. But in fact, what we saw is that this feature was still fairly low in early medieval times. So it actually suggests that the landscape must have been exploited in much the same way from the Middle Iron Age up to late antiquity, and that it was then only in the early Middle Age that management practices appear to have changed. And again, this is notable because it probably coincides with the abandonment of those earlier courtyard house settlements and the foundation of that new hamlet of Bosigran that Pete was talking about. So then, number 5, what we see is that enlargement then continues progressively throughout the Middle Ages and the post-medieval period, and you get a stone facing on the north side of the lynchet, whereas on the south side, the accumulation through uphill erosion, so that's number 6, is actually very limited. What I also want to mention is that for the other 3 sites that we investigated in this regular and irregular field system, we actually found that they adhered to very similar pattern to the one revealed at site 3, but this is the one that we investigated in most detail. So, but the 3 other banks also seem to have been constructed by taking advantage of that sloping topography and cutting down into Bronze Age and earlier soils, which predated the construction of the boundaries by at least 1,000 years. So next slide, Pete. Now, this entire construction history is something that would have been very difficult to retrace without OSL PD, and that's also apparent when you compare this final interpretation that I've just shown you on the left with our original section drawing that we made in the field doing our observations. So the stratigraphic context that we had originally delineated were clearly still quite flawed. Next slide, please. So I also want to briefly say something about that coaxial field system and that stony bank that we investigated there, which presumably dated to the Middle Bronze Age, so the later 2nd millennium. Now that feature had not been reused in later patterns, so you can see on the pictures that it's not that prominent in the modern landscape. It's quite a low bank, about 40 centimeters high. Next slide. And then again, what you see here is the OSL signals and the sensitivity. And you can tell that the sediment that's nearest to the RAB, nearest to your granite bedrock, again, has a very low signal intensity. And that's also in this case because it has low sensitivity and not because these are young soils that were exposed to light quite recently. And you can also tell, looking at the sensitivity, that the sediment on top of the bank, so the red dot is much more sensitive, the red and the orange dots, than the lower layers. So this is indicative of a constant cycle of erosion and deposition. So this is an indication of agricultural use. So next slide. And these are then the apparent doses and the ages that we determined for this feature. So when we excavated it, we actually again found this stone core, and the OSL dates that we get from it confirm that it was constructed during the Middle Bronze Age. We get a terminus postquem of about 1700 BC, 1619 BC, and we get a terminus antequem of 1100 BC. But you can tell from the graphs that you see on there. So these, all the dots that you see are those 40 smaller subsamples that we took. And so on the left one, the 1690 BC, these are all quite similar in range, but the youngest dates we get from that are 1300, 1400 BC. Whereas on the right, you can see that this this dating sample was much more mixed age. So that 1100 really relates to, again, to the youngest dates that we get from this sample. So tentatively, we've put the dating of this bank between 1690 and 1100 BC. But if we were to put just one date on it, it would be around 1300, 1400 BC. And then what you get is that the soil surrounding it have not been reworked since the Bronze Age, and that it's only the top 30 centimeters of soil that was in agricultural use over the last 2000 years. So here you actually don't get any samples dating to the Iron Age. So this Bronze Age low stony bank seems to have remained in use as it was until about 2,000 years ago, when agriculture picked up again, and it started getting covered by about 30 centimeters of sediment. Next slide. So if you want to find out a bit more about this research that we've been doing, you can read about it in a recently published paper in Antiquity. It's open access, so you can all go and browse for it, and I'm happy to send out the details again, maybe after the talk. And then I've got one final slide for my bit, and that's just to say that this OSL PD method, so it has been used in the past as well to study Mediterranean terrace systems. And as I've mentioned, I've also used it up in Northumberland to do field work there. And regardless of the context that we've been using it in, it's always proved very successful for providing this much more solid chronological framework for the construction and development of earthworks. And it also has the potential to be even more informative if you could combine it with other soil science methods like micromorphology or studying phytoliths or other kinds of plant remains. Because that way you could not only determine when farmers were using the land, but also how the soil was being cultivated. And also what was great, of course, here is that we were able to also combine it with this analytical survey that had already happened. So making it possible to really extrapolate all our findings to inform us about field systems in this part of the world on a much broader scale. So, and with that, I'll leave you. That was my bit, and I'll hand back over to Pete for some final thoughts.
Great. I hope you can hear me. Thanks very much, Soetkin. Well, you can imagine how delighted we were in Cornwall, having done all that work in the 1980s, to see that the basic outline of our understanding is confirmed by Soetkin's work. But the broad chronologies that we developed are okay, but now we have precision. And we also have, thanks to Soetkin's work, new details and new possibilities. It's good to see the coaxial fields fitting well with those on Dartmoor if they are 13 to 1400 BC. Very good to see those regular fields confirming what most people have thought, including ourselves, that they belong to the Iron Age, 3rd or 4th centuries. But what's really interesting with those is that they cut into Bronze Age soils about 1,000 years earlier than 3rd or 4th centuries BC, in other words, the coaxial period. And it makes you wonder whether those coaxial fields really did spread all the way along that plateau, which is why I've left Soetkin's pictures up. That bottom right is looking across Zennor. You can imagine the coaxial fields which are in that strip of rough ground in the very bottom here, perhaps spreading all the way along that garden as Hingston Randolph had it. So we do have coaxial fields here on Zennor Head and on Travail Head, and we have them also up here on the downs behind Tregarthen and Tremedda. The other exciting thing, as Soetkin has said, is the complexity of the post-Iron Age history of these fields. It's good to know that they really are Iron Age, but it's also interesting to know that their lynchets themselves have been adapted and changed, extended, maybe cut away like James Stephens did throughout the last 2,500 years for those irregular fields. And we can, I think, now finally confirm what people have often said. The National Trust have said it often enough, that these fields are amongst the oldest archaeological sites or features that are still in their original use anywhere in the world. So we can confirm, I think, that they really are significant, they're important, they have high value. We can suggest that Soetkin's results, as she herself suggested, are important not just for the story of Bosigran or Zennor, but for the whole of West Penwith. And in this map of West Penwith, that dull grey green, this colour, is the most exciting colour, because that is the presumed prehistoric and Roman period fields. And you can see Bosigran is around here, but you can see how much we might extrapolate from Bosigran in terms of understanding the West Penwith landscape. And we can also suggest that the medieval phase in West Penwith was much more substantial than we previously thought, although we were edging our way towards that with our landscape analysis in that diagram of West Penwith that I rushed earlier. And looking at the bigger picture again, I've contained myself, because this is the Cornwall Archaeological Society, to Cornwall. Here's West Penwith with its slightly different colouring. We've always been excited by the apparently prehistoric fields of West Penwith, and when we did our historic landscape characterisation, we distinguished those from the apple green, which is the medieval fields of the rest of Cornwall. But as we've done work in that medieval landscape of Cornwall in the last 25 years, since HLC has stimulated much more research, developer-led research in lowland Cornwall, we can see fields of brick shapes and similar patterns generally to those in Bosigran throughout Cornwall. And we could see that about 60% of Cornwall, which is the extent of that apple green, is truly ancient. And it emphasizes, again, if it needed emphasizing, the importance of Cornwall's historic landscape. Final slide is looking not back, but into the future of archaeological work. And having seen what Soetkin's done here in Bosigran and in Cornwall, and as you must believe her, I've seen the papers, it works in the Mediterranean and it works also in Northumberland. The potential of this technique of field profiling, where you can identify where to home in for your OSL dating, and therefore reducing the risk, increasing the precision, the risk that is of getting the wrong sample and not understanding your feature. This could be revolutionary for understanding earthworks, boundaries and buildings throughout West Penwith, but also throughout Cornwall. And most of these images are actually from Bodmin Moor. We can understand the tor enclosures, perhaps, if we could get underneath these substantial stony banks. We can understand the bank cairns, like the one that was excavated partly by the Time team on Routor. Underneath long cairns, presumed to be early Neolithic, like this one on Catsole. Underneath round cairns, like this one on Butter's Tor. Underneath the roundhouses, the walls of the roundhouses, the Bronze Age, Iron Age houses elsewhere in Cornwall. Underneath the possible early medieval transhumance huts under the stony bank, here on one on Brown Willie. Underneath the banks of these strip fields, we think they're pre-Norman. Can we confirm that by looking under the banks either of existing ones like here at Forbury, or underneath the hedges that have been formed on early banks in the enclosed fields of Cornwall? The other earthworks, this is King Arthur's Hall. Could it be a medieval pound, or could it be a prehistoric feature? We could establish that through OSL dating. Streamworks, here's a lovely streamworks on Westmoor and Bodmin Moor. We could look at the banks on the sides, but we could also look under the banks in the bottoms of the workings to get the latest working and possibly the earliest working of these multi-period streamworks. We can look under buildings, ideally under ruined ones, because it's a bit hairy going under an occupied one. But you can see, I hope, the potential for OSL dating, transforming Bosigran, but also transforming many of our puzzles in the archaeology of Cornwall's remarkable historic landscape. So I want to just finish by thanking Soetkin for her talk, but also thanking Soetkin for choosing Bosigran when she was looking around for another case study to go alongside the Northumberland one. And we hope to see more of Soetkin in Cornwall and her like and her technique. And finally, I want to say thank you all for your patience. We've overrun by quite a way, but I hope you found this talk interesting. Thank you very much.
Peter and Soetkin, thank you very much indeed. That was absolutely fascinating, and we are not in the slightest bit worried about you overrunning. We have nothing else to do. So I must say the technique does to me, as a really non-scientific person, verge on the miraculous, and it seems to suggest that you can, as Pete's just illustrated, we can now take datings on sites where in the past it just seemed impossible to find a way of actually ascertaining what came before what or what came after what. If I could just ask one question on my own account, Soetkin, is there any limit to the range of dates that this technique can deal with? You know, like radiocarbon dating is really only good back to about 55,000 years. Is that relevant at all?
Well, the range, I mean, you can confidently date things up to 200,000 years ago. So in terms of archaeology, that's quite all right.
Yes, no, that's okay. And is the equipment very expensive?
I think the portable reader that we've been using, I've been very, very lucky to have been able to collaborate with the Luminescence labs of the University of St. Andrews. I think if you were to buy it, so I've been using their equipment, if you were to buy it new, it costs about £20,000 or something like that. And then the cost for the OSL dating itself, normally a dating sample would cost about, let's say, £500 to get analysed, and a profiling sample about £100. Of course, if you do a large amount of sampling, these prices will decrease and stuff like that. And I've been doing a lot of the analyses myself, which has also helped cut some costs here and there. But let's say in general, it's quite an affordable methodology.
Yeah, well, I thoroughly enjoyed your talk. Now I'm going to see if there's anybody in the audience who would like to ask a question or make a point. I've put up the chat box, so if anybody has anything to say, or if you like, just unmute your microphone if you're in the audience and just ask a question. There's nobody there asking a question at the moment.
Can you hear me?
Hello?
Yes, we do hear you.
Sorry, Pete, it's Graham.
Oh, hi, Graham.
Would you like to say something about this 8th century horizon, AD, when all of a sudden there appears to be a different kind of working, which results in the formation of Luminescence on much earlier boundaries?
I could. I think the 8th century is becoming a crucial century, 8th century AD, sometimes called the long 8th century, so that we can steal a bit of the 7th and the 9th, not just in Cornwall, but throughout Britain. I don't know what the case is in Europe, Soetkin, but it seems to be around then that a lot of changes took place. It may be in Cornwall when the strip fields were established. It may be when the method of turning the ground changed from it being predominantly by hand to being by plough, and horse-drawn or person-drawn plough, or arms, that sort of thing. So you might have got the context therefore for intensification of both the agriculture and also the facilitation of moving soil, and therefore the more rapid building up of the lynchets. Is that what you expect, Graham?
Pretty much. I mean, I think the interesting thing is that Cornwall is participating in what is being seen much more widely. So whatever the new technology is, which is arriving at around that time, Cornwall is not stuck off somewhere down in the bottom left-hand corner. Cornwall is sharing in precisely the same things which are making Anglo-Saxon thanes rich and causing them to build hugely in terms of new granaries, corn dryers and so on. Some of the recent work that's been done on the Saxon period has been really interesting about the shifts in agriculture around that time. So it's very interesting that Cornwall is similarly seeing changes in technology, apparently, confirmed from this evidence. And we can then look for perhaps some of the other elements in the analysis that has been outlined elsewhere.
Yes, and we can take the queries that Soetkin's work has thrown up and look at other existing work, the work that was done on throughout West Penwith, the field systems, but also on Bodmin Moor and other parts of Cornwall. And we can design programs of work which test the ideas that are coming through as a result of this work.
Great, thank you.
Are there any more questions? If somebody'd like to ask a question, just unmute your microphone and speak away.
Yes, I would like to.
Oh, hi.
If you can hear me. Hi, Pete. Hi, Soetkin. It was really just a comment rather than a question, and that it was it's wonderful to see the scientific techniques which have helped to confirm broadly what we drew out of those surveys. But I think the interesting thing for me, I suppose, is the original justification for all of this work was the destruction of the sites through agricultural grants, actually by the government. When we asked for the survey to begin with, we had to justify it. And in order to justify it, we had to, if you like, do an assessment as to what were the areas that were most at threat of agricultural, inverted commas, improvement, and those areas that therefore, if we thought they were important, what should their future be? And remember constructing a map showing which areas, we thought in 1983-84 that the National Trust ought to buy. And the extraordinary thing is that today they own actually most of that area. And at the same time, whilst we were doing this, the very earliest thoughts about World Heritage Sites were going on. And rather bizarrely, we went off in the, not bizarrely, but perhaps understandably, we went off in the direction of an industrial World Heritage Site. And at the time, there was no suggestion, but either by the people who worked on Dartmoor or anyone else working in the Highlands or ourselves, that we ought to consider these relict landscapes or working prehistoric landscapes in any World Heritage Site. And it's rather interesting now to see that, I suppose, what, 30, 40 years on, we now have proof that not only West Penwith, but many other areas, there's wonderful, very early stuff in the Lake District, and of course Northumbria, as you say, let alone Dartmoor, and not so much Exmoor, but almost as good. And that this has never come up, and yet when you look at what we're showing here, and you compare it with, for instance, the Stonehenge landscape, which is in the news today, it's extraordinary that this hasn't come up. So perhaps one ought to think about this in the future, that the great demonstrable prehistoric landscapes of the country should be thought of for future designation, because let's face it, we haven't been very successful in maintaining the protection of these places, because we swither backwards and forwards between agri-environment schemes. We never got anywhere with scheduling. You can't list them. And we face perhaps an age of neo-barbarism, who knows, in terms of the environment and agriculture. Anyway, I'll just leave that with you. Thank you. It was a great lecture, really enjoyed it.
Age of neo-barbarism in almost every walk of life at the moment, Nick, actually, I think. Are we not?
Thanks.
Anybody else like to comment? If not, we will draw the evening to a close, but please, anybody with the last...
Yeah, I'd like a question to Soetkin, if I may. It's Malcolm Wright here. I've been involved in trying to persuade historic England to do some OSL dating at King Arthur's Hall, which Peter mentioned.
I remember.
Up on Bodmin Moor. At the present time, they consider the technique that you used here to be too intrusive to the banks. I've read about vertical OSL sampling, where you basically bore down, instead of taking a section out of the bank, you just bore down into the bank and take the samples as you go down. Have you any experience of that, Soetkin?
Not yet, but it's one of the things that we actually intend to do. When I showed you those two pictures of the field work that I intend to be doing, or the research I intend to be doing here in Belgium on the coastline, looking at old embankments of this marshland. What we want to do is, one, look at the embankments, but also look at old paleo channels. And of course, those most of them are well subsurface. So what we will do is bore down and then do OSL dating on those bore collected samples. The trouble is there, of course, that you lose a bit of context, and ideally you would need a borehole with a diameter of about 10 centimeters, really, ideally, to get optimal results. But that, of course, means quite heavy equipment. So Tim Kinnaird, who I've been working with at St Andrews, has informed me that you can go down to a 5 centimeter diameter. It's not ideal, but it would work as well. Don't know if that answers your question.
Yes, okay. All right. Well, there's some hope there then. We'll press on.
Good. Keep us informed.
Yes, do.
Thank you. Thank you very much.
I'm getting some nice messages in the chat box from people who have appreciated your lecture. Pete and Soetkin, from Peter Crispin, fascinating. Thanks, Pete and Soetkin, for a really interesting talk. From Karadik Peters, fantastic lecture. Thank you, Soetkin and Peter. John and Jill Moss at Tren Crom, thanks for a great presentation. Carolyn Kennett, thank you, Peter and Soetkin, really great talk. Goodness, there's 50 odd people in this audience. I hope they're not all going to say that. Otherwise, anyway, we had thoroughly enjoyed your talk. Thank you very much, both of you. And we certainly look forward to hearing your next plans and your next exploits, Soetkin. Can I just remind everybody before we go that the next lecture is on December the 10th, and Kathy Parks is going to talk about discoveries made in 2020, investigating landscape high on the watershed of Cornwall with all its important barrows and so on. And that will be at 7 o'clock again on December the 10th. Andrew Thompson also says very interesting. Thank you both. That's just the last one. Thank you for listening, everybody, and hope to see you next time. Good night.
Good night, everyone.
Thanks, Soetkin.